Okay, good evening. Everyone. I'm sorry. So, good evening, everyone. I hope my screen is clear and my audio is clear to everyone so that we may start for today's session. If someone can just confirm that, yeah, okay. So, basically, we'll be discussing the brief overview of the past 12 weeks in this lecture. So, we'll just start. So as you know, you can find the links for the slides and videos in the given drive and YouTube video links. So before going to week one questions, we'll just quickly see the overview of week one. Okay, so coming to the week one content here. So this was the brief electrical grid that we know, starting with the generating stations where we have the power, then we step up this power to transmit them through our transmission lines. Then at the end consumer end, we are again stepping it down to the consumer level with the help of the distribution or substation level transformer here. Then we have different regulatory authorities who are governing the power system of India. Basically, we can say they are Grid Control of India, CERC, and SERC at the state level, then the Central Electricity Authority, then Central and State Transmission Utility, and above all, we have the Ministry of Power. So these were some of the brief features of smart grid that we studied. Basically, here we are getting efficient transmission, faster restoration, cost is reduced, efficiency is increased, and greater integration of renewables. Then the four components of smart grid were smart infrastructure, communication, management, and lastly protection. So this was the basically we can say three seven major domains in the smart grid, which were bulk generation, transmission, distribution, and customer. And these were again interacting with the market domain, the operation domain, and the service provider domain. So basically, the bold lines are the communication flows, while the dotted line are the actual power flows. So from here you can see from generation to customer, this is the actual power flow path. While they are due to the smart grid environment, basically each of this domain is interacting with the help of communication flows with each domain for the efficient, we can say operation of smart grid. Then there were some standards for their interconnection. So after this, we will see the questions of week one. So here I would like you all to unmute or type or whatever you're comfortable to let me know the answer. So the first question was the typical voltage level of primary customer is anyone? Yes, sir. Okay, 66 kV. So We got one response for 66 kV. Anyone else would like to attempt? Yeah, we got 111 kV. Anyone else? We have to move forward because we have huge content to discuss. So it will be better if you answer, otherwise we'll move forward. So basically, primary level consumer, they will be at 11 kV, and the secondary level, those consumers are like consumer like us, which are connected at 400 volt. So this is the secondary level, we can say, or secondary consumer. And the primary level consumer, basically bigger industry which are directly connected to the sub transmission level. So they are connected at 11 kV basically. So the correct answer is 11 kV. Then second question, which of the following is not the characteristics of existing grid? Beware, this is existing grid and not the characteristics. So manual monitoring, failure and blackout, self-healing, one-way communication. Okay, one self-healing. Anyone else? Okay, another self-healing. Yeah, a smart grid is two-way communication. Currently, we can say it is. Huh, yes. So, anyone else would like to attempt this question? Yes. Yes. So I think most of you got it correct. So it is self-healing. Self-healing is the characteristic of smart grid where with the help of automatic switches and breakers, we are able to get the self-healing characteristics. But right now, it is not self-healing. Right now, we are having manual monitoring. We are facing failures sometimes and partial backouts, and there is one-way communication. Then the second question. Which of the following may not be a barrier in the smart grid technology? Lack of infrastructure, financial resources, regulatory framework, or integration of grid with very small renewable generation? May not be a barrier. Okay, we got one integration of grid. Anyone? So basically, we are facing lack of infrastructure, financial resource, and we are also facing lack of regulatory frameworks. But this integration of grid with very small renewable generation, it is not a barrier. Now also existingly, we are able to connect very small hydro stations in the hilly regions. We are also connecting solars and wind here. So this is not a barrier for smart grid technology. So, yeah, yes. Okay, okay. Then, okay. I would like to then each of you to unmute and answer. Basically, if you type, then I'll not be able to get it. Okay, next is according to IRIGB, basically the standard, the time synchronization accuracy requirement is up to what? Of zero point 0.5 microsecond, 1 microsecond, 2 or zero point 0.1 microsecond. So this is factual one. So basically this is 1 microsecond is the correct answer. Then the boundaries of customer domain typically consider which type of meters? Energy service load, energy service interface, energy service demand, or watt meter? Anyone? Okay, we got one energy service interface, energy service load. Okay, so the correct answer is actually energy service interface. Energy service load is actually not any type of any interface. So it is actually services interface with which the customer domain is interacting. Then the transmission network is typically operated by dispatch centers, distribution company, regional load dispatch center, or generation companies. Okay, one RLDC. Anyone else? Okay, load dispatch center. Anyone else? RLDC. Okay. Yes, so most of you are correct. This is that is RLDC only. So these are not anyway related to the transmission network. And for each region, the regional load dispatch center is basically looking after. So load dispatch center, here we know there are many types, right? SLDC, NLDC, RLDC. So only load dispatch center, this is not making clear which one. So it is RLDC. Then the service provider communicates with which domain? Generation, distribution, transmission, or customer? On distribution, anyone? Distrib distribution. See, the service provider will provide some services, right? So to whom will it provide this services, do you think? Yes. So it is customer basically. Okay. Then energy service interface communicates with other domains via which communication framework basically? So internet, home area network, local area network, or none of the above. In infrastructure, okay. Yes, it is correct actually. It is communicating with this customer domain with the help of this AMI infrastructure or internet. Then the interconnection of distributed resources with the distribution network. So it is governed with which standard? The interconnection of distributed energy resources with the distribution system. So this is a data-based question. So it is IEEE standard 1547.6. Yeah. Yeah, yes, sir. It is already uploaded in the drive link which I share, no? I will just show you that. So all these slides along with the content, you see the slides at this drive link. So there I have uploaded each week's content. If you see, if you, ha- yeah, so these questions I have taken from the each week discussion in the last. Only we have some discussion questions, no? So I think the PMRF, sorry, not PMRF, the NPTEL people must have shared with you some video and drive. Basically, in my PPT also, each time I am sharing this information, right? The slide link and video, also the recorded videos of each week. Okay. Then next question was, which of the following methods, data and power both are transferred in the same conductor, basically? Fiber, yeah, yes. So it is power line communication. Then we are coming to the week two content basically. So in the week two, here we are. The first question is the installed capacity of solar power in India. Actual question. So it is 9.1 gigawatt. The second generation of solar cell is which of the following basically? Silicon wafer, advanced thin film, one silicon wafer, anyone? Advanced thin film, anyone else? Actually, it is thin film. So, advanced thin film is the next generation, and silicon wafer is the previous generation of thin film. So, second generation is thin film. Then, the conversion efficiency of a polycrystalline silicon solar shell, it is lying in which range? 12 to 15, 11 to 14, 10 to 13, or 9 to 12? 11 to, yeah, so it is 11 to 14. Okay. So a PV array is operating at an open circuit voltage of 370 volts, short circuit current of 28 ampere, and maximum power of 8 kilowatt. Then what is its fill factor? 0.88. Can you tell me what is the formula for the fill factor? Yes. So it is VOC times ISC. So if you do this, you will get basically 0.77. Yeah, 8,000 upon 317 to 28. No worries, no. So this is 0.77. Then the series resistance in a solar cell modeling is representing which one? Its characteristics, basically load resistance, wire resistance, top and rear contact resistance, or all of the above. So basically in solar cell modeling, what we are trying to do? We are trying to basically model the characteristics of a PV panel in terms of an electrical circuit, right? True. So the series resistance, it is representing which part or which characteristics of a physical PV panel. Basically, it is the top and rear contact resistance. So the resistance, true. Huh. So the basically the contact resistance, it is being modeled as a series resistance in the equivalent electrical circuit of this solar cell. You have a shunt resistance. Can you tell me what characteristics basically it is representing? So the PV will produce the electrical energy depending upon the irradiance, right? Amount of so we can say that characteristics will be represented by the shunt part of the solar cell model. Okay, so with increase in solar irradiance level, the open circuit voltage and short circuit current will increase or decrease. So what will happen if irradiance increases? What about VOC and what about ISC? So if you remember the plots of irradiance level with respect to this open circuit voltage and short circuit current, so basically both of them will increase with the increase in irradiance level. Then which state is the maximum producer of wind energy in India? Maharashtra, Tamil Nadu, Gujarat, or Rajasthan? Yes, sure, sir. Thank you, sir. Uh, yeah, so it is Tamil Nadu, correct. Then in wind turbine, which type of generator we are using? DC generator, synchronous, true. So it is DFIG. Then the total power of a wind stream is related to the velocity streams by which relation? Yes, yes, it is Q. Then, what about the maximum efficiency of a wind turbine that we can get? Okay, okay, yes. Then we'll come to week three. So, which of the following is not a type of mechanical energy storage? Air, gravity, hydro, or latent? Yes, pumped hydro. Okay. Basically, in pumped hydro, we are having two reservoirs, right? And we are storing the water, we can say, in these reservoirs. And with the help of the coordination between these two reservoirs, basically, we are managing the pumped hydro. So here also we are storing it, right? So that is a type of again mechanical energy storage, whereas latent is type of heat or thermal, we can say, energy storage. In which combination of the storage technologies is not feasible for a hybrid energy storage system? So supercapacitor and battery, lithium ion and lithium ion and sodium sulfur battery, vanadium flow and lithium ion, or none of the above. Basically, for hybrid energy storage, what characteristics do we require? Hybrid means here we are utilizing two type of energy storage. So we require that one should be of high power type and the other should be of high energy density type, right? So a combination of these is created to form a hybrid energy storage so that we can get both their characteristics in a single energy storage. So which of the following do you find as a combination of high power and high energy density type of energy storage? Actually, so none of this combination will work. So these are both high power type. These are both high energy type. These are also high energy type. So none of these is the correct answer. Then match this type of energy storage. So which of these is a chemical energy storage? Flywheel, battery, fuel cell, or superconducting magnetic energy storage? No, basically chemical will be fuel cell. Then mechanical, yes, it is flywheel. Electrochemical, yes, it is battery. And electromagnetic is superconducting magnetic storage. Then which of the following storage type is high energy density type? Supercapacitor is high power type. So, no. High energy means it is able to store the energy over a long period of time with greater efficiency. So, and high power means which can re-inject the basically energy into or out of very quickly. So, suitable for transient applications, whereas high energy density, they are suitable for steady state applications so that we can store the energy or basically our electrical energy over a long period of time. And high power, no, basically it is lithium ion, which is the more high energy density type, for which we are using it for our now most of the battery energy storage that we are deploying and also the EVs. So lithium ion. Yeah. So yeah, basically lead acid is having some concern with respect to their, we can say, disposal and due to all this. So it is not favorable. But this type of batteries is also used in some of the basically three-wheeler e-rickshaws that you find. So although they are using these kind of batteries, but their usage is not recommended. So lithium ion are little more expensive, but they are better. Then a 12-volt battery with 500 ampere hour is at 80% SOC. So what is its depth of discharge? Yes, so it is 1 minus SOC will be your DOD. So it will be 20%. Then the reverse one, if it is 500 ampere hour is at 80% SOC, then what is the energy that is being stored right now in the battery? What amount of? 500. This capacity is 800 and it is at 800, 80% SOC now. Yes, so it will be 400, right? Then the distribution network planning problem is which type of problem? Linear, mixed integer linear, integer non-linear or non-linear. This one basically we were studying with the help of uh, energy storage siting problem or sitting or placement of the storage. So, okay, so any placement or sitting problem will involve binaries. And the power flow equations, they are inherently nonlinear, but using some of techniques, we are linearizing them so that our problem becomes a MILP type. Select the advantage of mathematical programming approach, low computation burden, global optimal, short convergence, or simple formulation. Yes. Anyone else? Yes. So basically, we had heuristic and we had, mm, yeah, and mathematical type. So heuristic had a problem of trapping in local optimal, whereas our mathematical approach, it can guarantee the global optimal solution. So it is their advantage, we can say. Then the indication of SOC is best given by specific gravity, temperature, color, or level of electrolyte. So basically, it is given by the specific gravity of the electrolyte. Then coming to week 4, so we have a digital fault recorder. So what is its sample rate? So this one, specific gravity of electrolyte. Okay. The sample rate of a digital fault recorder, it is 64 to 356 samples per cycle. Then a circuit breaker monitor data is also formed in power signal, current signal, voltage signal, or COM format. Okay, anyone else? Basically, if you remember, there was a this COM format is the answer for this. So the data was recorded in this format. Basically, all this information of the making current, breaking current, and all this, so they are stored in COM format. Then, which of the following phasor estimation technique can filter out the DC components? DFT, half cycle DFT, recursive DFT, or least square estimation technique? Yes, anyone else? Yes, least square estimation is the correct one. So these are they are not able to filter out the DC component or the constant term basically inherently. So in GPS, each satellite is covering what percentage of the globe? 42%. Yes, it is 42%. Then in wide area monitoring technology, the non-operational data is used in fault recorder, protective relay, Baker monitor, or all of the above, non-operational data. Okay, actually, it is all of the above. So all these are used to store the non-operation data. So if a signal is having a fundamental frequency of 100 Hz, it is being sampled at a frequency of 30,000 kilohertz. Then the number of samples per cycle is, so it is basically, anyone, it is F sampling by the F fundamental. So if you do it here, what is the answer? Yes. So here you have already 1000, so it is 300. Then a 100 volt, sorry, 100 hertz signal is being sampled at 5000 hertz. Then what is the phase angle between two successive phasors estimated by the DFT? Anyone? So firstly, how many samples you will get? Yes. So 50 samples, they are corresponding to, we can say, 360 degrees, right? One complete cycle. So one sample will correspond to, yes, it will be 7.2 degrees. Then the relay percentage of security is defined as number of correct trips per failed trips, or failed trips per correct trips for number of trips, or failed trips per number of trips. Yes. Yes. Yes, it is number of correct trips per number of total number of trips. And what is the advantage of a digital relay? System integration, auto reclosing, self-checking. Yes, yes, it is all of the above. Then a signal's first zero crossing, it is occurring at 0.01 time instant, and the ninth zero crossing is occurring at 0.05. Then what is the frequency of this signal? This is the formula basically. And what is M here? How much is M? What is? It is ninth zero crossing, right? So it is 9. Solving this, what you'll get? Sorry, 2, 2, 2. Hmm. So here you will get the frequency of the signal is basically 100 hertz. Then coming to week 5, determine the superimposed negative sequence impedance at PCC if the magnitude of the negative sequence impedance before and after islanding is 50 ohm and 70 ohm respectively. So, do you remember what it was? It was Z2 post or pre. It was post minus the negative sequence impedance in the pre-islanding condition. So what you'll get here? So after it is 70. So it is 20 ohm. Yes. Mhm. These questions I had discussed during the week 5 content, right, Lo? Okay. Yes, it is from the content, right? So, and these are simple formula only. So, no heavy computation is being used here. So, you make it right. Then the disadvantage of current injection based islanding technique scheme is DER operate in unstable region, high non-detection zone, degradation of power quality, or all of the above. So here you are externally injecting some signal, right? So that will interfere with your system, which may lead to degradation of your power quality. So these type of islanding detection techniques basically face the power quality degradation issues. Then the QX's current injection causes sinusoidal component to exist in dash during the islanding condition. So here you remember, right? We had a fundamental frequency, let's say omega naught, and with this Q axis current injection, basically we are doing something like your sine C plus sine D operation. This will result in different types of frequencies, basically, where this will be sometimes added in your fundamental, sometimes subtracted from your fundamental. So basically, they will exist in the frequencies. Then the penetration of this distributed energy resources changes magnitude of fault current, direction of fault current, both or none. Anyone? Yes, so they will affect both magnitude and direction. Depending upon their place, they are leading to bidirectional fault currents, and they can also like change the level or magnitude of fault current. So it is both. And if a overvoltage relay is tripping, then what does it implies? Okay, so this active power matching will be, so if you remember this diagram, you had over voltage, sorry, under voltage, over voltage, under frequency, over frequency. So whenever the over voltage is tripping, that means you are having negative APM basically. Your negative APM will imply that this, right? And under this condition only you will have over voltage. If it is positive, means PD will be greater. Then at that time you may be facing under voltage, not over voltage. So over voltage will mean generation is more, and that will mean the APM or active power margin is negative. Similarly, a microgrid has a 300 kVA load at zero point 0.9 power factor and 300 kilowatt of solar generation. Then the solar generation is connected to an inverter of capacity 330 MVA, and find the active power imbalance when islanding condition is present. So you have basically your S as 300 kVA. Then what will be the real power demand PD? It will be SD times power factor, right? So that is given as 300 and power factor is given zero point 0.9. So what we'll get here? 270 kilowatt, right? And what about your generation from solar? It is 300, right? It will be PD minus PG. So this will be negative 30 kilowatt. This is clear, right? Then in the next question, similarly for the same one, find the reactive power imbalance. Yes, sir. Okay. So similarly, can you find the reactive power imbalance for the same set of questions? And this is 330 kVA. And what about QG? How much is QD, anyone? So it will come as 130.77. And what about QG? How can we find QG? S inverter. This will come around 137.47 kVR. So your delta Q will be QD minus QG. So how much it will be? It will be minus 6.7 kVR. Okay, so which is the disadvantage for a rock off? Basically, rate of change of frequency, passive identic detection technique, so determination of threshold, large non-detection zone, vary with load and generation inertia, or all of the above. Anyone? So in passive identic technique, what happens basically? If it may be frequency, voltage, or anything, so we check it with some threshold, and if it falls beyond that threshold, then we detect the islanding technique. But what will be the value of this determination of this threshold? That is a challenge for this type of method. So this is also a challenge for Rokov. Then all these techniques, they are also having large non-detection zone. And since it is with respect to frequency, so frequency will also change when there is a load change or when the inertia of the generator changes. So basically the answer is all of the above. So all these are the disadvantage for Rokov as a islanding detection technique. Then a positive superimposed negative impedance applies what? Okay, positive will be this is 0 greater than. That means here Z2 post is greater than Z2 pre. This will implies your V2 post is greater than V2 pre. So what does this imply? There is an increase in voltage. Voltage will increase whenever there is increase in generation, right? Basically, in your post condition, you have excess generation. So your delta P is PT minus PG. So PG will increase, then this will be negative. So this is negative APM. Limitations of AI based identity detection technique is power quality issue, large non-detection zone, difficult for practical implementation, or they drive into the system into unstable mode. Basically, they are difficult for practical implementation since they require huge amount of data for their training purpose, which is a challenge. So it is the limitation. Then coming to week 6, how are the IDMT relays, time of operation, and time multiplier setting related? Directly proportional, inversely proportional, equal. So basically, it is directly proportional to the DNS. Then the analogy of a full tank in car and SOC estimation is often called the fuel level, fuel capacity, fuel gauge, or all of the above. So it is basically fuel gauge. So it is like a meter where you can see the amount of fuel remaining. Similarly, the SOC estimation will tell you the amount of energy remaining. So it is the analogy that is. Then the factors considered during cell selection of battery is weight of cell, depth of discharge, ambient temperature, or all. Yes, it will be all. Then the operating quantity in superimposed positive sequence method of fault direction is default voltage, pre-fault current, superimposed fault current, or superimposed fault voltage, which is the operating quantity. It is a superimposed, yes, it is superimposed fault current. Then a boost converter's output and input voltage are given, then calculate the duty ratio. This is 1 upon 1 minus duty ratio, right? And the output is 40 by 10. What you get the D. Point 0.75. Yes, correct. Similarly, for a buck boost converter, the output and input voltages are given. Then calculate the buck boost converter duty ratio. 0.6. It will be 0.8. Then, if the output and input voltage are basically reversed, so here we are going for basically boost operation and buck boost converter. Then, what is the buck boost converter duty ratio? So here you'll get 1 by 4 as 0.2. Okay. Then the grid forming power converters can be expressed as a ideal voltage source with low output impedance, high output impedance, zero output impedance, or none of the above. High output No, it is actually low output impedance. Then the operation time limit and desired coordination time interval of both the protective and relays is within. So it is basically 1 second and 0.3 second. The function of a microgrid ancillary service in islanding mode is black start support, voltage control support, grid loss reduction, or all of the above. In islanding mode, what it will give? Yes, correct. It will give black start support. Then coming to week 7, a large droop coefficient in DC microgrid leads to less voltage deviation, large difference in current sharing, large voltage deviation, or none of the above. Yes, basically this is your V versus P, and for same power sharing, basically the difference in voltage will be large. So it will be large voltage deviation. Then in mode 2, adaptive group control, energy storage devices and the distributed energy resources, they are operating in which mode? constant power mode, group control mode. So the energy storage will operate in group control mode and the DG will operate in the constant power mode. Then the main objective of the grid side converter in DC microgrid is to regulate the DC grid voltage, active power balance within the DC microgrid, both A and B or none of the above. The grid side voltage converter. So it is responsible to regulate the DC grid voltage and it is also responsible for the power balance within the microgrid. So basically it is both the functions. Yes, yes, it can. It We are talking about this mode two. So basically, there were three modes, if you remember. Mode, so for that particular mode, it is operating in constant power mode. But if you remember in mode three, it can operate in group mode also. Then the AC and DC microgrids they are connected through interlinking converter, cycloconverter, DC-DC converter, or all of the above. It was through the interlinking converter, right? Dial C. Yes. So the fastest time scale of operation is for local control, secondary control, central control, or none of the above. Yes. So this is in seconds. After this, it is fastest we can say. After that, secondary control will come into action. And in the topmost or the slowest one is your central control. So the answer is local control. Then, which of the following does not rely on any communication for their operation? Yes. So in distributed, there is communication, and centralized, obviously, there is communication. In decentralized control, basically, they do not rely on any communication among them. The disadvantage of the centralized control scheme is single point of communication failure, high computational burden, both or none. Yes, so what happens here is we have a central controller here, and since all are communicating with this one only, so it will experience single point of communication failure. That is, if this node is failing, then everyone is in dark. Similarly, high computational burden here also. So it is both A and B. Then the disadvantage of passive synchronization scheme are difficult for practical application, may lead to circulating currents, require close coordination and communication, or none of these. So in passive synchronization scheme, what we were doing, we were basically manually, yes, because we are manually checking that which is the time for grid synchronization. So manually, when we are checking, always some difference in voltage and phase may occur in voltage, and that difference will lead to circulating currents. Then the power management strategies are challenged under loading condition due to constant power load, voltage dependent load, frequency dependent loads, all of the above. Constant power. Voltage dependent loads are also we need to consider, right? Similarly, frequency also, because they will change the dynamics of operation basically. So it is all of this type of load are a challenge for the management strategies. Then coming to week 8, which type of variables are used in optimal PMU placement problem? Binary, integer, continuous, binary and continuous. So it will contain optimal placement problem will contain binary, and there will be other power flow variables also. So those will be continuous variable. There will be angle also. These will be continuous. So both binary and continuous. Then sensor attacks are which type of attack? False data injection, man in the middle, denial of service, distributed denial of service. It is both binary and continuous. Because in the optimal power flow problem, if you remember, there will be power balance equations, right? Right. So delta I minus delta J upon the line reactance, let's say. So the line power flow and the voltage, bus voltage, basically angle, these are continuous variable, right? They can lie between, we can say, minus 30 to plus 30. So these are continuous variables. And binary variables will correspond to the optimal placement problem, basically on which bus you want to install the device. For that, you have to take binary variables 0 and 1 for that. So hence binary and continuous. Then this sensor attack is coming under which category? So in the sensor type attack, basically, they will it will come under the false data injection attack, basically. Means at the sensor, let's say the sensor had sensed a value x, so they will change it to delta x, maybe plus or minus anything, and that way they will manipulate basically, and hence they are coming under false data injection type attack. Then why cyber anomaly detection methods are needed? For continued normal operation of system, isolate the compromised or faulty part, for increased cyber resiliency, or all of the above. Yes, so for all these advantages, we need to have cyber anomaly detection techniques. Which of the following sources can provide inertia? DFIG, energy storage, synchronous generator, or all? Yes, so because this is also a heavy machine, then here we are storing the energy, so that can also provide inertia. Synchronous generator, we all know it is a source of inertia to the system. Hence, it is all of the above. Then the virtual synchronous generator can't provide which type of ancillary service? Inertia, primary frequency control, voltage support, or none of the above? Cannot. Primary frequency. It is a type of storage only, so it can provide primary frequency. It can also provide inertia support and voltage support. So basically, the answer is none of this. It can provide all this type of ancillary service. Virtual synchronous generator. No, it is a type of storage device only. So it is named as a virtual synchronous generator because primarily it is used for emulating the characteristics of a synchronous generator, which is inertia and frequency. But at the time of requirement, it can also provide Q support, that is voltage support. Um, Not supercapacitor, we can say hybrid energy type storage. So, which demand side management strategy is more reliable compared to others? Load growth, peak clipping, flexible load, or load shifting? Yes, I'll be uploading this slide in the Drive link. So there you can find these after this today's session. Peak clipping will again it will be type of a load shedding, right? So that will be not more reliable. What will be more reliable is load shifting. So it is load shifting. Then which demand side management strategy is used in DC microgrid to reduce the peak demand in AC system? Yes, correct. So it is load shifting only. Then the load profile of which of the following type of consumer are confidential? Yes, so commercial is the right answer. Then demand response program applied to yes. See, because let's say there are two manufacturing companies A and B, and suddenly in the market they are seeing that A is selling its goods at a, let's say, cheap products, or let's say it has decreased the price of the goods that it is selling. So that means some kind of we can say plan they have changed, which B is unknown of. So let's say this was earlier the 24-hour profile of power consumption of this factory A. And let's say now it has changed to, let's say, like this. So what if B has this information, then it can note that during these intervals, the factory A is suddenly consuming more power. So it can have a rough guess that which unit or which part of the basically factory is having number of units, right? So which strategy it has changed, it can guess with this power demand profile basically, and it can also then try to innovate in this area. Let's say during these times, let's say unit C of the factory is running, so it will try to also improve its unit C so that it can also match the price of this factory A. So for that, we are saying that this information of their load profile is confidential. Okay. So the demand response program applied on residential customers. They are specially named as home energy management, house energy management, residential energy management, or consumer energy management. Yes, it is home energy management. Then coming to week 9, the rating of the DC input capacitor should be less than the grid voltage, equal, greater, or any rating. So basically, we want to send power from DC to AC side, means your AC side voltage should be greater than the, sorry, DC side voltage should be greater than the AC side. That way only the power can flow in this direction, right? So the rating of the DC input capacitor should be greater than the grid peak voltage. The function of the bleeder resistor in an inverter is discharge energy stored when inverter is not in operation, to equalize SOC of cells through passive balancing, both A and B, or none of the above. Bleeder resistor in an inverter. Both, okay. Anyone else? No, basically the function of this resistor is this, but not in an inverter. This is for different application. So in an inverter, it is basically discharging the energy stored. If it is the question would have been only the function of leader resistor, then both A and B was correct. But since it is specifically asking for inverter, so option A is the correct answer. Then TFIG is what type of machine? Squirrel cage or slip ring? Yes. Then the number of cells connected in series provide high current, high voltage, high power, high voltage, correct. Because in series, the amount of current will be the same. Then passive balancing possess what size, cost, charge, fast or slow. So passive balancing means it is small in size. Then what about cost? Cost will be low. Charge is wasted, and it will be slow balancing. So size is small, cost is low, charge is down. This is the correct answer. Then when the battery is being charged, the terminal voltage decreases with increasing charging rate, increasing state of charge, increasing temperature, or all of the above. All no charging rate increases means voltage will increase. Yes, increase in temperature. Yes, thank you. Then why cannot we have an onboard charger in a DC fast charger? It is more expensive, it will occupy more space, it does not allow sharing of charger by multiple users, or all of the above. Yes, you are correct, it is all. It will be expensive. True. So basically, yes, in four-wheelers, basically, so we are concerned about the weight of the battery because battery is already bulky there, and this charger will also add on to that weight. Okay. So this was then the main aim of droop controller in a AC/DC hybrid microgrid is frequency at DC side, frequency at AC side, voltage at AC side, none. So in AC side, it has to maintain frequency. In DC side, it has to maintain voltage. So here, frequency at AC side. The interlinking converter enforces which of this? The interlinking converter is between DC and AC microgrid. It will try to equalize the voltage this side and the frequency this side. So A is the correct answer. Then the short-term system operating conditions are maintained by power management strategy, energy management strategy, or both. Short-term. Whenever it is short means it is power, and whenever it is for longer duration means it is energy that we are concerned about. So the short term is for power management strategies. And supercapacitors are a type of capacity oriented, access oriented, or both. Even so it is access oriented. So you can see there were two types. In the capacity, we had lithium ion, and supercapacitor is access oriented. Okay. Coming to week 10, we have okay. Which of the following is responsible for providing the reference AC voltage and frequency in the islanded AC microgrid? BREF and FRF. Who can provide load, battery, diesel generator, or PV? Yes, correct. Diesel generator is the right answer. Then DG is capable of injecting P only, or injecting P at cost of Q, absorbing Q, or injecting both P and Q. Yes, it is capable of both active and reactive. Then a wind generator output is processed through dash to feed the power to standalone DC system. Wind will be AC, so AC to DC. Yes, and then DC to DC. So AC to DC, DC to AC. Then in a two inverter system with similar inverters, if current references of the current loop are same, then which current will exist? Interactive, common, or some harmonics, or none of the above? Only interactive or only common current? Hmm. Yes, correct. It is only common current. Then the purpose of diesel generator in AC microgrid is regulate voltage, regulate frequency, supply power to load during low renewable, or all of the above. Yes, all of the above. It can regulate voltage and frequency, and when renewable are low or there is no renewable, it can provide the power to the load. Okay. Battery and supercapacitor are connected to DC microgrid through boost converter, buck boost, or any kind of the above. Yes, because sometimes we may want charging and sometimes we may want discharging. So for facilitating both operations, we need buck boost type operation. Then the interconnection of two local DC grids is feasible for when the voltages are equal for both grids, unequal both A and B. Yes, so it does not depend upon the voltage of the grid. They may be equal, they may not be equal. Their interconnection is feasible. Then, which is the disadvantage for passive filter? Limited adaptability with system, cannot supply active power, cannot mitigate current related power quality issue, or all of the above. Okay. So it is basically limited adaptability with the system because of passive filters, the aim is for any of the filter, we don't want any active power support from the filters, right? And it cannot also mitigate current related power quality issues, so it can basically, so it is limited adaptability with the system. Then the DStatCom in this unified power quality controller acts as shunt passive filter, shunt active, series passive. So uh, this is a active type filter, and it is having both shunt and series. So it is shunt active filter. This is active filter. Then which of the following component of inverter is independent of grid impedance? Interactive, common, or both? No, sir. Actually, we are in the week 10, we are ending, and 2 more weeks we will wrap up quickly. The session was from 4 to 6. No worries. So, the answer, anyone here? Yes, sir. Today, 4 to 6, I have a session today. Actually. After this, also, another session is there, I think, sir. Yes, sir. No worries, sir. No, grid side impedance. Basically, common current which is flowing out of this. You remember this is for parallel operation of inverters. So let's say one inverter and two inverter. So the common current which will flow out, that will depend upon the grid side impedance. But the interactive current which is flowing between these two inverters, so that will be independent of the grid side impedance. So it is basically interactive. Then which of the following is the most critical state requiring voltage or reactive power support? Steady state, dynamic state, transient state. Yes, it is transient state. So here we were basically scheduling the fast acting Q resources, right? Then coming to week 11. So charging of batteries is preferred during which mode? Peak hour, off peak hour, excess demand in isolated, or none of the charging the batteries. Yes, off peak hour is the correct answer. Then during off-peak hours, which operation is desired from a microgrid? Supply power to the grid, consume power from the grid, and charge batteries, draw minimum power from grid and maximum from microgrid. Neither supply. Yeah, so grid is an off-peak hour, so we will like to charge our batteries in this condition and consume power so that during the peak hours we can discharge our batteries without relying on the main grid. Then for developing various control mechanisms for renewable based microgrids, we are design open loop, closed loop, mixed open closed loop, or what type of control loops? Yes, closed loop, because we want feedback from the device under test so that we can monitor it whether it is performing correctly or not. So we design closed loop control schemes. Which of this is the highest energy consumer? Industrial, commercial, residential? Yes, industrial. Then the architecture of distribution system is mostly, yes, it is both A and B. So it is both. The grid emulator can act as DC source, DC load, electronic load, or all. It can act as all, so DC load also. So the answer is basically all. No, this grid emulator was basically, we can say, the device in the lab setup. So various type of modes it is having or settings it is having. So it is not a physical grid type of thing. It is a device which is there in the lab, which can be used for different purposes. Obviously, it is main name suggests that it is emulating the characteristics of grid, but it is having other modes of operation also where it can act as load. So this is the component in the lab setup. So according to the requirement of the test, it can we can change the function there. Then in grid connected mode of operation, the DC microgrid, this semicron IGBT stack is what? So it will be bidirectional, right? And it is an inverter, so it is a DC to AC converter between DC bus and the grid. So it is B. Then in autonomous mode of operation, the DC microgrid, it serves which of the loads? So autonomous means this switch. Yes, so the switch at the PCC is open. So PCC loads it cannot supply. And within the DC microgrid, we can also have AC loads which are connected through converters. So it is both DC and AC loads. Then coming to week 12, the high deviation in power in case of asymmetrical fault is basically due to asymmetrical. True, true. So asymmetrical fault will have negative sequence current. Then AMT type simulator, the time step is, yes, it is very fast. It is in the order of microsecond. Then for transient study, the power converter needs to be modeled in small time step, average, any or none. Yes, small time step is the correct one. Then which type of energy storage is suitable for peak energy management? High power, high energy. both. True. So then in passive distribution system, voltage problems are mostly evident in head of the feeder, end of the feeder, across the whole feeder. Yes, end of the feeder. Then in peak energy, uh, head of the feeder, but it will be more severe in the head because if head is, let's say, at dot 0.95, then still also we can manage, but this 0.95 will imply that here it may about 8.5 or something. So always the most stress is at the end of the feeder. Okay. Then in peak energy management demonstration, the grid emulator was acting as a DC source, AC source, or load or energy storage. Yes, it was AC source. Okay. We are at the end of the presentation. If anyone has any doubt, or I think you have another session. Uh, yes, sir. Okay, okay, sir. This week 12 I uploaded today only, so I was uh, okay. This. Uh-huh. Oh, okay. Sorry, sir. Okay, okay, okay. Today only I'll post it. And thank you, sir. Okay, okay. If we will close the session, I think we have another session after this, so you may join there.